Welcome to example 3. This is problem solving with maximum minimizing differentiation problems. So my third example, I've chosen a bit more difficult and a lot of words. So a plant pot has a vertical cross section in the shape of a trapezium. So you can see the trapezium here. The vertical height of the plant pot is x, and the two parallel sides of the trapezium is y and 3y respectively. The length of the trapezium is x plus y. So again, typical question of having x's and y's in the same question, or two letters, so we need to eliminate one. Given the area of the vertical cross section is 20, show that the volume is this. So we need to find the volume, and they've given us some information about the cross section. So the first thing is about finding the volume of any prism. So it's the cross section times the length. Now, in this case, my cross section is a trapezium. So for a trapezium, if you remember from lower down the school, the formula is a half A plus BH, which is half your parallel sides. Add your parallel sides together, half them times by the height. So I'll just give you a little bit of a sketch there, A, B, and height, because you might not remember that due to having the formula sheets. Now, so therefore, if I find the area of my trapezium, we are in the situation I've got a half times 3y plus y times x. Well, 3y plus y is 4y, so it's technically a half times 4y times x, which therefore is 2xy. Sorry, it's got to be written that way. So that is the cross section. So then I need to times it. For the volume, we need to times it by the length. So if you look here, this is my length, x plus y. So therefore, my volume is the 2xy, so the cross section, times my length, which is x plus y. So if I expand that, let's have a think. Yeah, I might expand it. We get 2x squared y plus 2xy squared. Now the situation is, again, we have our volume in terms of x, but we've created our volumes in terms of x and y. So we now need to use the fact that the volume of the cross section, the area of the cross section is 20 centimeters squared. So we found the cross section, it's 2xy. So I know that the cross section, which is 2xy, is equal to 20. So I need to eliminate my y's. So we're going to make it a y equals. So y equals 20 over 2x. So y is equal to 10 over x. Again, simplifying down. So like before with previous examples, we're going to substitute in the y value to eliminate these values here. So looking at this again, we've got our volume as 2x squared y plus 2xy squared, and we know that y equals 10 over x. Handy hint, always rewrite it at the top of the page, because then you're not going backwards and forwards. So we're going to plug and play. So my volume is 2x squared times 10 over x plus 2x. Now, y squared, remember that you've got to square both of them. So we end up with 2 times 10 is 20, x squared over x plus, now this will be 10 squared is 100, x squared is x squared. So we end up with 200 x over x squared. Now we're aiming for b equals 20x plus 200 over x. So again, let's think about where we simplify. So first off, because it's a show that question, I'm going to think about writing everything down. So we have the v there. I can so straight away you can see the x's eliminate there and the x eliminates there, and I've got what they wanted. So it shows that my volume is 20x plus 200 over x. So that's part A done. Now remember, show that, write everything down. It is actually quicker to keep writing stuff down than to try and do it in your head. So please make sure you've got your structure sorted. It's so important that you have a good structure for these questions. Remember that if you couldn't do this bit, you can still do the next bit because it will all be based on the information they've given us. So, part B. Use calculus to find the value of x that minimises the volume V. So again, we need to find x, and then we need to find that it's a minimum. Okay, so there's two parts to this always, and it's really important. Now, in the last video, I made a mistake and called it algebra instead of calculus because I was just going for it. So we know that they have given me V equals 20x plus 200 over x. Okay, now we know that the minimum slash maximum value occurs when dv in this case over dx is equal to 0. So again, be careful with your terminology. Also be careful that you need to make sure that you're kind of stating what you're doing. So if I've got v equals 20x plus 200, so that is technically x to the minus 1. I'm going to differentiate it. So that becomes 20 minus, because minus 1 times 200 is minus 200. And we're going to take 1 away from the power, so it becomes minus 2. And I prefer to write it as 20 minus 200 over x squared. So we know that the minimum maximum occurs when dv over dx equals 0. So I can set it equal to 0. I can then, I'm just going to take this across. So we're in a situation that 200 is equal to 20 over 20, x squared. So therefore, we're in a situation that I can say 200 divided by 20 is x squared. That's a bit pants. I was kind of hoping for a 2. So therefore, we are in a situation that 10 is equal to x squared. So the square root of 10 is equal to x. Now that is equal to plus or minus root 10 in a way. But again, remember, because it's a length, it must be the positive value that we take. So let's see what that is as a decimal. Ugh. So x equals 3.1622766. So I'm just going to check what I've done. Okay, so now it's asked us, this is technically the value of x. It's then asked me to find that it minimises the volume. But again, we can't make that assumption. Remember, to see if it's a minimum or maximum, we need to use the second derivative. So to find if it is a maximum / minimum, we need to use the second derivative. Now, remember that we're using dv over dx. So we had that dv over dx is equal to 20 minus 200. Now, if you look, we've got it as 200 over x squared. But again, that's the minus 2. So again, I'm just going to write it straight away as x to the minus 2. And then we're going to do d squared v over dx squared is equal, well, because this is a constant, it's just going to disappear. So then we've got minus 200 times minus 2, which is plus 400. And then x, take 1 from the power, so it becomes minus 3. So to check if it's a maximum or a minimum, we are now going to substitute in our value of x. Now, I am just going to use root 10 for ease. And again, I could say that d squared v over dx squared is 400 times by 1 over root 10 cubed. Okay, because we've got this situation going on here. Now, well, technically it's 1 over that cubed, but it's okay. Sorry, let's write that correctly. So 400 times by, so if it's to the thing, it's to the root 10, and that bit is cubed. I seem to have gone bracket happy there, so sorry. So let's figure out what that value is using my calculator. So again, I'm just going to go on 400 times by and I'm going to use my fraction button because it just is a lot easier. 1 over, and I'm going to do root 10 to the power of 3 equals, and I have 12.649. So remember your statement. So as d squared v over dx squared is greater than 0, it is a minimum value when x equals root 10. Okay, so very, very similar, even though they both involve shapes. But again, it's that you put it equal to 0 to find your x value, but then you've got to prove if it's a maximum or a minimum. And remember that they'll be looking for your layout and key points. So remember your statement at the end. Now, the last part, as of any of them, is find the minimum value of the plant pot. Now, this question hasn't stated to any number of significant figures or anything like that, so I'm just going to put root 10 in. If you took it to 3 sig figs at the end, they'll be probably quite happy with that. But again, be very careful that you don't do anything too soon. So if you round too soon, you end up with numerical errors. So b equals 20x plus 200 over x. So we're just going to sub in our value of x that we found. So my volume is, 20 times root 10 plus 200 over root 10. So again, going to use my calculator. 20 times root 10. Close bracket. Delete. Be careful when you're doing a root to make sure that you kind of go to the left to cancel it down. Plus, I love a new calculator due to the fact that you can just put your divides in as a fraction. Equals, so we've got the volume as 40 root 10. So therefore, we are going to format decimal, and it is 126.491164. So I'm going to say it's 126 centimeters cubed, and that's to 3 sig figs. So because in the start of the question we ended up with centimeters, so technically if we're thinking of units, I would have centimeters here as well. So that is kind of the third example of how to do differentiation and solving problems where it's maximum and minimum problems.